Hi, welcome back to our Honors Geometry playlist. On this video, we're going to talk about how to simplify radicals. So there are a couple different methods you can use. One would be to break down each number into a product of a perfect square and another whole number. So maybe 96 would be, 2 and 48. But neither of those are perfect squares. Or I could do 96 divided by 4 and get 24. And that works, but there's a larger number that I could find. So typically I want to start with the largest possible number. I would check if 100 goes in, it doesn't. Neither does 81, neither does 64 or 49. Neither does 36. But I can divide 96 by 16 and get 16 times 6. So I could rewrite this as the square root of 16 times 6, or the square root of 16 times the square root of 6, which simplifies to 4 root 6. Now this method is incredibly useful if you already know all of your perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Because a problem like 2, I can see that 49 goes into 98. And I could simplify that to 7 root 2. Now you could also do the prime factorization, where you would take the prime factors of each number, like this is 2 and 36, which is 9 times 4, which is 3 and 3, and 2 and 2, and find your pairs. So there's 1, there's another one. So that would be 2 times 3 times the square root of 2, or 6 root 2. It works a lot better with smaller numbers or numbers that have relatively few primes. So like this is 5 times 9, 3 and 3. So then I can simplify this as 3 root 5, because I had a pair of 3's. So the 3's would be outside. Now what do you do when you have a number out front, like on number 6 or 7? Let's take a look at number 6. I can find my factors of 48. So 48 I can rewrite as 16 times 3. Or this is 4 root 3. But I can't forget the 10 that was out front. So what this is saying is 10 times 4 root 3. Then I can simplify and combine like terms to get 40 root 3 there. Or on number 8, 5 times the square root of 180. And I could do 2 and 90, 9 and 10, 3 and 3, 5 and 2. So my pairs would be 3 and 2. This would be 3 times 2 times the square root of what was left over, the 5. But we can't forget about that 5 that was out front. So maybe I should do that in a different color. I'll do that here in a different color as well. So this would be 30 root 5 if you were to simplify all of that down. There's a quick reminder on how to simplify radicals. Check out our video on how to solve the geometric mean problems in